All right, people, this is question 9. Okay, so here you are requested to prove the Chord theorem, right? So you have been told that in this diagram below here, PT is a tangent to the circle PQR at P. Okay, so you need to prove that you need to prove the theorem which states that QPT is equals to R. Okay, so whenever you're proving Chord theorem, I don't know how they taught you in the classroom, but this is how I do it always. Okay, so we need to prove that QPT is equals to this angle R. So the first thing that we have to do, you have to make sure that you construct a line passing through the center O. So this here, it will be your center O. Okay, so you construct a line passing through the center O to the circumference of a circle. Once it touches this line, you can produce any letter. It can be D. Let me just use D, and then you join it D and R. Okay, you join D and R like this. So whenever you're done with this, it means now you have created the two angles. So this can be angle R1 and R2. Here it can be angle R1, P1, P2, and P3 and P4. P3 and P4. Okay, so now since you have constructed this line, it means now you have to start with your proving. The requested to prove is QPT, which is equals to angle R1. Okay, P4, we need to prove that P4 is equals to angle R1. So in this case, you are going to look at the 90 degrees, right? So it means here angle P plus angle P3, P3 plus P4, I mean. So you're going to say angle P3 plus P4, it is equals to 90 degrees. Why do you say this? It is because of the radius perpendicular to the tangent. So it's radius perpendicular to the tangent. Okay, it's radius perpendicular to the tangent because you have constructed this line. Okay, so from the center to point P, it's radius perpendicular to the PT, which is the tangent. So now, since we have this diameter, we know that angle subtended by the diameter is equals to 90 degrees. It means that R1 plus R2, it is equals to 90 degrees. Why do you say this? It is because of angle in a semicircle. Angle in a semicircle. Okay, so this is 90 degrees as well. Angle in a semicircle. So we have got something like this, right? So now, since we know that we have 90 and 90, right? It means now you can check the angles in the same segment. So angles in the same segments, just because of this circle here, it will be angle R2, and angle R3. These are two angles in the same segment because there is this butterfly here, a butterfly theorem. Okay, so now we are going to say angle R2. Well, let me start with P3. It is equals to angle R2, which is P3 is equals to angle R2. Why do you say this? This is because we have angles in the same segment. So these are the two angles in the same segment just because of this butterfly. Okay, so now you can come here and conclude that P4 is equals to P1. But before we can do the conclusion, you can try to prove it because if this is 90 and this is 90, once R2 it is equals to P3, it means that automatically R1 it will be equals to P4. But you can just prove using the workings, okay? Since all these are P3 plus P4 is equals to 90 and R1 plus R2 is equals to 90, therefore you can say P3 plus P4 it is equals to R1 plus R2. Okay, so there is no reason for writing this because you have proved that these two angles they form 90 and these two angles they form 90 as well. So now you can make P4 the subject of the formula. P4 it is equals to R1 plus R2 minus P3. Okay, so I just I took this P3 to the other side, or actually to the right hand side. So now P3 we know that our P3 it is equals to R2. These were the angles in the same segment, so therefore you can just substitute here and say this is R1 plus R2 minus P3. It can be written, or it can be replaced by the R2. Okay, so now R2 minus R2, it will give us 0. Therefore, you remain with what? With R1. So therefore, now we have proven that P4 it is equals to P3, and this P4 here, it's angle QPT, which is equals to angle R, as you were requested from the question. So you are done in this case. So this is a Chord theorem. Thank you very much.